Assalamualaikum warahmatullahi wabarakatuh. So today we're going to present about our assignment, which is finite element trusses analysis. We are from group 7. The team members are Hakim, Hanis, Ainul, me, Husaini and also Hidayah. The contents for our presentation consists of introduction, methodology, result and discussion, lastly conclusion. First of all, I will briefly introduce what is truss and also finite element analysis. Firstly, truss. The definition of truss is the triangulation of components in order to maintain a sustainable structure. We have some truss design assumption which consists of only the axial forces will be carried by the truss member. Second, the node or connection between members are constructed as pin joints to prevent moments from being transmitted to the truss members. Third, we have only the nodes are affected by external loads and responses. Lastly, the truss should be in a plane in a general. We also know that there are many types of truss member, such as I section, angle, T section, cube section, square section, and also channel section. We also have many types of trusses, which are simple truss, planar truss, and also space frame truss. Okay, now we're going to move on to the finite element analysis. The definition of finite element analysis is that the process of simulating the behavior of a part or assembly under given condition so that it can be accessed using the finite element method. In this report, the software used is Abaqus. The reason why we use Abaqus is to obtain the forces and reaction and stresses of finite element trusses. In our case, two-dimensional truss problem. To verify the result obtained from the software, we use method of joints for the hand calculation. Thank you. That's all for the introduction. The next content, which is methodology, will be presented by Nur Hidayah.
To continue the presentation, here is the methodology. Generally, in finite element method, it consists of 3 stages, which are pre-processing, processing, and post-processing. As in the flowchart, analysis starts with the step of modeling. In this stage, an input file which contains an engineer's design is created. As for this project, we need to insert part, or in other words, we need to draw the truss structure as in the figure attached, known as Pratt roof truss. After the truss structure and all the inputs such as the boundary condition, materials and etc. is established or is defined, then the evaluation and simulation takes place during the second stage, which is the processing. And in the last stage, visualization takes place. Here we can achieve the report, image and animation from the output file that has been generated. In this slide, on the left hand side, there is a flowchart attached which consists the overall flow using the Abaqus software. The modules involved in this project are part, properties, assembly, step, load, mesh, job and finally the outcome, which is the result. In the part module, we create the design, which is the truss structure with correct dimension, and before the procedure starts, we need to determine the approximate size. In our case, the approximate size is 15, while the modeling space is 2D planar and it uses the wire type features. After that, we need to define the properties where the young modulus used is 200 giga for steel material and the Poisson ratio is 0.3. Then we continue to assembly modules, step modules and the load modules. In the load module, applied load was defined at certain nodes on the bottom chord, where there are 5 concentrated forces in y direction that pointing downward. Then the boundary condition, which are roller and fixed point, also been defined. After that, the mesh module continue the step process, where we need to define meshing with approximate global size 2.5 and define element type. And before the result analysis, we need to submit analysis in job module and check the status of the analysis in the job manager until it is shown completed. And finally, the results generated will be in the visualization module. To prove the results obtained from the finite element analysis, which is the Abaqus software, manual calculation is necessary. We use method of joints in determining unknown forces acting on truss members. The summation of forces in x and y direction, as shown in the slide. To calculate the bending moment in the truss system, we pick a point with the highest reaction forces as the point of rotation for the bending moment. Again, the same equation used, the summation of moment is established and it is equate to 0. So there are two equations used for the method of joint to determine the reaction forces.
This is the result obtained by using the Abaqus software. As we can see here, the deformation and reaction was shown. Before that, we will go through the legend of the figure so that we can understand it better. As you can see, the black wire line is a design for the model before simulation, and the color line is a deformed structure including the nodes and element. The blue color number is an element, and the yellow color number was a node, and also the orange triangle was the boundary reaction. As you can see here, the number of elements is total of 21. At the element 6 and 21 is the stress, which is quite high, and the number of nodes was total of 12. And we can see here at the node 4 and 9 is where the reaction force take place. As for the reaction force, there is no change with the fixed boundaries, and there are slightly change to the right of the x-axis was the roller. As for the deformation scale factor, we use the standard one, and the maximum stresses is around 433 megapascal. We will obtain the result of the stress component, which is at 11, the special displacement data, reaction force data. Based on the result shown was the stress component, which give the element number was a total of 21, and also the stress value, and also the special displacement data which show the number and also the value. And at the reaction force data, as we can see, there are reaction at node 4 and 9, but at node number 4 is a small number because finite element analysis using an approximate number which is a very small, and we can see later inside the calculation we will prove based on the actual number. So in this process, we will compare only the reaction force at the CY and KY, which is 250 kN. So we can proceed with the next slide.
For this section, I will explain about the hand calculation. First of all, we have to draw our free body diagram of the whole truss structure system. The free body diagram only involves the forces and the reaction forces only. Then the free body diagram is as such. So as you can see at point C, the system is supported by pin support, while point K is supported by roller support. Then we can make an assumption. Our first assumption is that all forces acted upward are positive, and our second assumption is that all moments acted anti-clockwise are positive. Then we can write our equations of equilibrium. Our first equation is that the summation of forces in x direction is equivalent to 0. As you can see on the free body diagram, only one force, which is Cx, acted in x direction. Therefore, Cx is equivalent to 0. While the other two equations of equilibrium, which are the summation of forces in y direction and the summation of moments about point C, can help us to find what is Cy and Ky. For the next slide, we can solve all of the unknowns. From the moments equation, we can find what is Ky, which is equivalent to 250 kilonewton. Then we can substitute this Ky into equation 2, which is equation of forces in y direction. Therefore, we can get Cy is equivalent to 250 kilonewton. Finally, we can found all of the unknowns based on three equations that I've said just now. Cx is equivalent to 0, Cy is equivalent to 250 kilonewton, and Ky is equivalent to 250 kilonewton.
So, in conclusion, our group is assigned with a Pratt roof truss where we need to determine the forces and stresses in each member and also the displacement at each node. Firstly, the truss was analysed through a FEA software, the Abaqus software. In the Abaqus software, we created an input file, which is the construction of the truss. Then the boundary condition was also defined after the modelling process. It then generates a simple result that we want, which is the reaction and displacement and stresses acting on each node. Furthermore, the results obtained from the Abaqus is then proven through a hand calculation. Method of join were used and we are able to establish the reaction forces and the moment at the point. The final solution of the hand calculation give out a similar value as to the software. Hence, we are able to validate that the result from the software is true because we are able to prove it through the hand calculation. That's all from Group 7. Thank you.